Here in lesson 1.5, we will review complex numbers. And complex numbers have imaginary units in them most of the time. They don't have to, but one thing that we will review is the imaginary unit, which is I. So we'll talk about imaginary numbers. And then with the complex numbers, we'll add, subtract, and multiply them. We'll talk about complex conjugates and then find complex solutions of quadratic equations. And for that, we'll just use the quadratic formula, which we reviewed in 1.4. So imaginary numbers, the imaginary unit I, essentially it's used for whenever we have the square root of a negative number, because we have always said that if, for example, I have x equals, or x squared equals -4, and then I would try and take the square root of both sides so we could solve it, we'd get x equals, and then square root plus or minus, but there's no two numbers that multiply to -4, right? Because 2 times 2 is 4, and -2 times -2 is also +4. So in terms of a square root of a negative, we would always just say there's no solution. However, in a more advanced mathematics, we use the square root of -1 to be considered an imaginary number. Now, imaginary numbers, just think about them as another dimension on a graph. And I actually have a video, a YouTube video that explains them pretty well. And I'm going to attach that to your notes. So if you haven't watched that as the intro, please make sure you do. But that explains how it's a different dimension than just the x and the y that we're used to working with. So we can simplify answers by using the fact that square root of -1 is I. And then that also gives us then, if we square both sides, like if I took this and we did squared and squared, we would get I squared equals -1. So we'll use that a little bit in this lesson as well. So then if I go over here and I want to do the square root of -4, what I would do is I would say, well, this negative is my imaginary unit and the square root of 4 is 2. So my answer would still be x equals plus or minus, and then I like to write the 2 first, so the square root of 4 would be 2, and then that negative means we have an imaginary number, so plus or minus 2i would be my answer for the square root of -4. And then before we keep going on, remember we said we're going to talk about these complex numbers. And complex numbers are basically a combination of real numbers, which are the numbers we're used to working with. Whole numbers, negative numbers, zero, fractions, anything that's not imaginary. And then it's a combination of those and imaginary numbers. And it can be written a plus bi. A lot of times that's how it's written. And the a represents the real number, the number that's not imaginary. And then the bi, because it has that I with it, this is your imaginary unit. So it's like a combination of the two. Some more definitions with the imaginary unit here. So by adding and combining, like I said, real numbers to the imaginary unit, you get your complex numbers. And here's that a plus bi that I was talking about, that's standard form. So you can read through the definition algebraically. But like I said, essentially breaking it down, it's the combination of a real number and an imaginary number. And you can read through the equality of complex numbers. It makes sense. Basically, it says two complex numbers are only equal if this a and c value are the same and this b and d value are the same. So pretty simple there. All right, so now let's do example 1 from the book, operations with the complex numbers. So example 1, we're adding, and this is kind of like when you're combining and adding like terms. So we have the parentheses that are grouping. I like to rewrite it without the parentheses, right? And everything is positive here. So if I distribute the 1, that's still 4 plus 7i, and then a positive 1 here would be positive 1 minus 6i. So I like to rewrite it without, and then basically you're combining like terms. So I have the 4 and the plus 1 that are the real numbers. They are not imaginary. So 4 plus 1 is 5. And then we have the 7i, positive 7i, and negative 6i that are imaginary. So 7 minus 6 is a positive 1. So we just say positive I, so plus I. So it's exactly like combining like terms. Another one where we are just adding. So I'm going to start by rewriting this as just 1 plus 2i plus 3 minus 2i. So in this case, our real numbers, we've got 1 plus 3 is 4. And then the imaginary numbers are positive 2 minus 2. So those add up to 0, but this is still 4 is still considered a complex number because it's equal to 4 plus 0i, right? I could write it like this. This is written like a complex. But this 4 is the simplified, and we always want a simplified answer. So we could write it as a complex number with the 0i, just to show that there's no imaginary unit and it's still considered complex, but we always want to give the nice and simplified answer. So our answer here would just be 4. And then subtracting, when we're subtracting, we just want to make sure we distribute the negative through. That is the subtraction. So here we've got 3i, but then we're subtracting, so minus times a negative 2, negative times a negative would make that a positive 2. Here we'd have a negative times positive 3, so that'd be negative 3i. And then same idea here, it's like we have a negative 1. So negative 1 times 2 is negative 2, negative 1 times positive 5 is negative 5, and that's our I. So as long as you remember to distribute the negative, we're going to do the same thing and combine like terms. So for the reals, we've got 2 minus 2. So that these add up to 0 now, which is fine. And then for the imaginary numbers, we've got positive 3 minus 3. That's 0. So we're left with a negative 5i. So our answer could only have imaginary, just like it could only have the real. So this would be like saying 0 minus 5i. Right, like we talked about before, but we want to give the simplified answer. And letter D has a little combination of both, so let's go through. Here we're just going to have 3 plus 2i. Next we're adding, and when we're adding, nothing changes, so plus 4 minus I. And then we have a negative 1, so we want to distribute negative 7 minus I. So combining, we've got 3 for a real number, 4 for a real number, negative 7. So 3 plus 4 is 7, minus 7 is 0. So these zero out. And then for our imaginary units, we've got positive 2i. So 2 minus 1 is 1, minus 1 is 0. So that zeroes out as well. So your answer on this one is just 0. Okay, which is okay. 0 is a number. 0 can be an answer. There's just nothing left.